Carbon. Carbon.
Carbon.
Carbon.
Carbon.
Carbon.
Carbon.
Carbon.
Carbone.
Carbon.
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 What is carbon?
If you haven't realized it yet, our group has decided to research carbon. Now, humans use carbon in our everyday basis. I mean, when we drive our car uses fuel, and fuel has coal in it, and coal has carbon in it. Carbon can also be found in things like methane gas and crude oil. Now, even humans, even the earthling themselves have carbon in it, as when we breathe out air from our lungs, the air has carbon dioxide in it, which is a form of carbon. Now, when we go to school, we also use carbon in the graphite that we use to write with our pencils. And even our ancestors, the people in Giza who built the pyramids, that limestone that coated the pyramids also is a form of carbon. So when your family goes out on a barbecue, just remember that that charcoal also has carbon in it.
In the world of jewelry, carbon is contained in diamonds and other crystalline solids. You must be wondering that, how do I know that something has carbon in it? The answer is that everything living on Earth, like plants, possesses carbon in one way or another. Here are some pictures of jewelry that have carbon in them.
So what about the history of carbon? The word carbon comes from the Latin root called carbo, which means coal. It was originally founded in 3650 BC by L. Lavoisier. Carbon as coal was used by our ancestors in prehistoric times. It was also been used as diamonds long ago.
One of the biggest reasons why carbon is easy to get and use is because it is the 15th most abundant element on the Earth and 5th in the universe by mass. In other terms, carbon is commonly found in the Earth's crust.
Alright, let's talk about the molecular details of carbon. The density of carbon is 2.25 grams per cubic centimeter. And carbon has an atomic mass of 12.011. The boiling point of carbon is 4,827 degrees Celsius. The melting and freezing point of carbon is 3,550 degrees Celsius. At room temperature, carbon is a solid. In each carbon atom, there are 6 protons and 6 neutrons, and roughly 6 electrons. This is an image of atomic structure of carbon.
The chemical symbol for carbon on the periodic table is C. 2 compounds carbon can be found in is hydrogen cyanide and cyanide, and both of these can be used in chemical warfare. Carbon is very essential for life to sustain on Earth. We wouldn't even be here today if it weren't for carbon. Now, scientists have created a carbon cycle in which we can clearly see the different stages of the cycle and how they react to our environment. The first stage of the carbon cycle is called photosynthesis. The plants feed off the carbon coming from the atmosphere and the sun. Then, consumers like animals and us eat the plants containing the carbon. Then, the waste coming from the human and animals decompose into the soil and create something called fossil fuel. Now, the dead animals of the humans and of the animals also play a huge role in placing the carbon in the soil. When we burn the fossil fuel, we release carbon back into the atmosphere, and the cycle starts all over again. Now, here's a detailed diagram of the carbon cycle.
One of the biggest reasons that carbon is non-metal is because it does not have a metallic luster and does not reflect light. There are 118 elements on the periodic table, which means that the category carbon only makes up about 13% of the periodic table, which is slim compared to the largest category.
In the periodic table, carbon is located in group 14, and it is the sixth element. It is in the second row, and it is in a family called the carbon group. Although carbon is very common in the real world, it is in a small category within the periodic table. While most elements on the periodic table are metals, carbon is the non-metal category with only 15 other elements.
Hello, and welcome to our experiment. Today, we'll be experimenting what dry ice, so I have dry ice here, and what effect does that have on the pressure inside its container. So to start this experiment off, I got 2 water bottles, and I put approximately the same amount of water in each of those bottles. Then, I'm going to put 1 scoop of ice in one of them. So I'll just quickly pause the timer on. Pause. We're going to do the second part of the experiment, and in that we have the same water bottle, or the same kind of water bottle, but just I put more ice in it. So that the reason why I put more ice in it was to see if more dry ice in the bottle creates more pressure. So ready? The same amount of water, and I'm gonna put it in here and I'm gonna cap it. Ready? 3, 2. Cap this.
ચાલુ જ રાખજો. એ ફૂટ્યો ફૂટશે સાઈડ ફૂટશે. હા ચાલુ રાખજો.
Clearly we can see in the second experiment that if you put more dry ice in the plastic bottle, it will create more pressure, causing the bottle to explode faster. In the first experiment, we only put 1 scoop of ice, and that took approximately 1 minute and 11 seconds to pop. But now, in this one, it only took 41 seconds. So we can see that if you put more dry ice, it can create more pressure. I hope you guys enjoyed the experiment, and thank you for watching.
Did you know more compounds that contain carbon are known to us than the ones that don't?
Did you know about 20% of the weight of living organisms is carbon?